Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present an introduction to epoxy coating systems. Coating system contain a polymeric film former system, resin and curative, special additives, modifiers, and pigments. These systems can be solid, for example powder coatings, that do not contain a solvent, or liquid, 100% solids, or liquid that have been dissolved in a suitable solvent mixture, which called solvent-borne, or dispersed in water, which are waterborne. Film former polymers in coating can be classified as either non-convertible or convertible. In non-convertible coatings, a film is formed when the solvent is evaporated and shellac, cellulose nitrate or acetate, chlorinated rubber, and vinyl and acrylic resins are of these examples. In convertible materials, the film former becomes cross-linked and the coating occurs. Drying oils, varnishes, and thermosetting resins such as alkyds, phenolics, epoxides, and polyurethanes are of examples of convertible film former polymers used in coatings. Surface coating is often performed for the protection and decoration of surfaces. Special functions can also be included in the coating, for example, antifouling properties for ships' bottom paintings or the protection of food and beverages in metal cans. Various coatings techniques also exist which can be adapted for specific applications depending on the chosen coating system and the required coating thicknesses, coating speed, and the type of finish. This table presents the application of various film-forming materials in coatings. Epoxy resins can be used for can and drum coatings, heavy-duty maintenance coatings, automotives, primers, top coat and respray coatings, pipe coatings, marine coatings, coil coatings, and for metal coatings. Due to inherent and engineerable properties, epoxy systems are perfect materials for coating formulations. In this video, an overview of the use of epoxy systems in coating application is presented. Epoxies show unique properties which can be used in coating applications. There are no volatile involved in these systems and they have good mechanical, chemical, and electrical properties, relatively low shrinkage during curing, excellent protective features, and perfectly tunable rheological properties. Moreover, the versatility of curative agents makes it possible to formulate epoxy coatings to be cured either at ambient temperatures or at elevated temperatures. Epoxy resins' abrasion resistance is good, their flexibility and impact resistance are comparably good, and their chemical resistance to alkalis and acid is perfect. Epoxy resins show perfect chemical resistance properties and good mechanical properties, but they are susceptible to UV radiation and are not often suggested for outdoor applications. Among epoxy resin, cycloaliphatic resins exhibit good outdoor aging properties, as they contain no aromatic rings which absorb the UV radiation and starts the degradation process. In addition, cycloaliphatic epoxy resins do not contain chlorine and other halogens, which makes them a perfect choice for electrical applications. The plethora of curing agents available for epoxy curing is also a merit in the formulation of epoxy coatings. In fact, by employing the right epoxy resins and the proper curative, it is possible to formulate an epoxy coating system to meet almost every specific requirement. Surface preparation is primary requirement before applying the coatings. The principle discussed in the video on the surface preparation for epoxy adhesives and the surface preparation methods, mechanical abrasion, chemical etching, etc., discussed earlier are also involved here. The applied surface preparation depends on the type of substrate, rheological properties of the coating, interfacial tension of the coating, etc. And finally, any surface feature that alter the film formation on the coating must be amended. If the aim of coating is more than just surface covering, some other specific treatments must also be considered. For example, to strengthening the glass surfaces, water vapor exposure to optimize the hydraulic durability of the coating is required. Primers also can be used to improve the wearability of the surface or for protection purposes, especially for hydrated surfaces. The primer must adhere well to the substrate surface and exhibit good bonding to the coating. Coupling agents, which react readily with inorganic substances, and the epoxy resins are also employed in primers in coating applications of inorganic substrates. In this system, the rheological properties of the epoxy formulation have been amended by employing the use of solvent systems to adapt it for specific applications. Primarily, the rheological properties of epoxy coatings depend on the nature of the epoxy formulation, for example, its epoxy type, molecular weight, fillers, pigments, additives, solvents, etc., as well as the working conditions, for example, the applying temperature. Solvents are chosen based on their miscibility with the coating system as well as their effect on the rheological properties of the coating formulation. Also, other properties of solvents, for example, vapor pressure, toxicity, and cost have also been considered. Common solvent system for epoxy resins include xylene, methyl ethyl ketone, and methyl isobutyl ketones, MIBK, or a mixture of these. Normally, the apparent viscosity of epoxy coating systems are temperature dependent and they are normally within the range of 0.05 to 1 Pascal second or 0.5 to 10 poises. In addition to the epoxy coating formulation and the proper solvent set, for a successful coating application, other factors such as the condition of the surface prior to coating, concentration of the solution, curing technique, pot life of the solution, and etc. have to be considered. The presence of pigments and fillers also affect the rheological properties of the coating, as after the addition of these additives, the coating may be either Bingham bodies with the yield stress, pseudoplastics, or thixotropic. Epoxy resins coating have been successfully used to protect and repair road and bridge surfaces, where the combination and accumulation of many different factors such as freeze-thaw cycles, spillage by vehicles, road greasing, etc. can cause defect in the surface. For these conditions, usually liquid epoxies, cold torr extenders, and amine hardeners at ambient temperature are used. Some of other applications of epoxy resins coating for road and bridge include the repair of scaling concrete roads, the repair of slippery surfaces, protecting against fuel spillage, providing lightweight surfaces for bridge decks, incorporation of waterproof membrane between concrete and an asphalt topping, as well as providing the road marking and color surfaces. Embedding or casting, potting, impregnation, and encapsulation by epoxy resins is a common practice to protect electrical or electronic devices. Protective functions such as exclusion of moisture, oxygen, salt spray, solvents, other chemicals, and microorganisms can be provided by embedding protective epoxy coatings. To protect the device from mechanical shocks and vibrations, epoxy encapsulation can be applied. Bisphenol A resins and their mixture with Novalox can be used for potting. Cycloaliphatic epoxy resins, which have been cured with anhydride hardeners, exhibit excellent weatherability and contain no chlorine and aromatic rings. These systems are perfect for encapsulation. In these systems, fillers such as silica, talc, clay, and calcium carbonate, mica and chopped glasses can be incorporated. Epoxy systems have also been used for coal tar coating, which consists of three main components: pitch, epoxy resin base, and curatives. In these systems, both liquid and solid epoxy resins can be used as the base, and various curatives can be employed for the coating formulations, including amines, amine adducts, and polyamides. These systems can be formulated as solvent-based coating based on solid epoxy resins with EEW of around 500, solvent-based coatings prepared from liquid epoxy resins, as well as the more common type, high solids coating prepared from the liquid epoxy resins. In epoxy tar coatings, epoxy improves the thermal stability and water resistance of the coal tar, whereas coal tar improves the water resistance of the epoxy. Therefore, these coatings exhibit excellent flexibility, impact resistance, abrasion resistance, and hardness, and also they are resistant to wide range of environments, including freshwater, seawater, sewage, detergents, diluent mineral acid and alkalis, exhaust gases, etc., which make them extremely durable, especially to protect concrete and metallic surfaces in submerged and non-submerged conditions. Coal tar epoxy coatings can be used in various applications, particularly in tank linings, pipes, foundations in aggressive soils, sewage works, effluent plants, chemical processing plants, and dock and harbor installation. However, coal tar coatings are not suggested for tank lining materials for gasoline and other hydrocarbon fuels. The choice of coal tar pitch is significantly important to achieve a good coal tar epoxy coating. Often, in hot climates, the tar is blended with the curative in advance to avoid unwanted reaction of the tar and the base, which may increase the viscosity, and also to reach a better cohesion between the tar and the base resin. Deep coating is one of the oldest and easiest ways to apply epoxy coatings. Compared to spray coating, it provides minimum material waste, and also in one set of application, all the immersed part can be covered with a layer of epoxy. However, in this type of application, the object has to be immersed into the fluid epoxy coating solution, which means that the large deep tanks are needed, meaning that this method might not be convenient for large objects. In addition, in continuous deep coating applications, the system is open and evaporation of the solvent, which affects the concentration of epoxy formulation, is an issue. For successful deep coating application, it is important to minimize solvent evaporation by employing a proper tank design. Moreover, there should be no reaction between the coating solution and the material with which the tank has been made of. Other important factors in deep coating include the desired coating thickness, temperature control, anti-contamination measures, degree of agitation, dipping and withdrawal speed of the object, etc. Epoxy emulsions and other water-based epoxy coatings are also preferred in an attempt to omit the need of solvents and reduce the health risks associated to these applications. To produce a stable epoxy emulsion, often a suitable surface active energy is also employed in addition to the mechanical shearing, which is used to reduce the particle size of the epoxy in the medium. Emulsifiers often contain a hydrocarbon tail and a hydrophilic head, perfectly tuned to make stable emulsion of epoxy resins that suit the applications. Generally, to establish a stable epoxy emulsion, the droplet size of the emulsion has to be less than 1 micrometer. Moreover, the aggregation and particle coalescence of the droplets have to be avoided by employing a suitable emulsifying agent. The stability of the emulsion is also affected by temperature variation, as it affects the hydrophil-lipophil balance or HLB balance of the surfactant. Therefore, two main criteria have to be satisfied for the selection of a proper emulsifier. First, the emulsifier must be able to efficiently reduce the interfacial tension between water and resin, and second, it should form protective film around the resin droplets. Regardless of the emulsion stability and performance, the rheological properties of the emulsion are also of great importance. as the emulsion must be applied either by dipping, spraying, or electrodeposition. For deep coating applications, drainage of the emulsion from the object as soon as it is removed from the emulsion determines the film thickness and its quality. Even drainage is needed for an even coverage and to ensure the quality of the film formed. In the sparing application, the formation of fine droplets in the emulsion is crucial and it is dependent on the rheological properties of the emulsion, as large droplets can splash where they hit, which consequently result in a more or less grainy surface and finally coating with imperfect specular reflections. Compared to solvent solution epoxy systems, in the epoxy emulsion systems more heat is required as the film formation involves the evaporation of water. The flexibility of the emulsion epoxy coating can be improved by the addition of alkyd, polyester, or acrylic resins, and for the curing, polyamines and polyamides may be employed. For can coatings, higher molecular weight epoxy resins, for example, with molecular weight of 15,000 to 20,000, which have been initially dissolved in a solvent and then dispersed in water, are employed. These systems can be cured with either a melamine or a urea formaldehyde resins. The baked films have to be resistant to pasteurization conditions and comparably flexible, conditions which are required for beer cans. Water-based epoxy resin coatings can also be formulated for both anodic and less commonly cathodic electrodeposition for appliances and automotive industries. Compared with spraying applications, in electrodeposition application, it is possible to obtain more uniform coatings, and also the wastage of the coating is minimal as the loss due to the overspray is eliminated. Water supply and storage systems are vulnerable to contamination. The source of this contamination could be corrosion, either in reinforcing steel in concrete tanks, steel tanks, or in the carry-on, which happens in the municipal water supply pipes. The corrosion is also much more severe in this system, as here bleaching powder might be used to disinfect water, which emits chlorine in the forms of chloride ions. This chloride promotes the corrosion process via an electrochemical reaction. In addition to the corrosion and its associated pollution, in concrete tanks of potable water systems, there is a risk of growth of microorganisms and biological matter, which makes the water unusable for human consumption. These indicates that the surfaces in contact with potable water have to be protected. However, normal paints and galvanization fail to serve this purpose. Under such conditions, non-toxic epoxy coatings are the best choice to protect the substrate from corrosion, abrasion, or chemical attack, which consequently prevent the contamination of water. The other important application of solution epoxy coating is in paints. Epoxy paint is simply a paint. It is a latex acrylic product that has a small amount of epoxy in the mix, and it is used for flooring or painting applications. Epoxy paints provide a tough, durable protective coating that is easy to maintain. Because of the presence of epoxy in the medium, epoxy paint is corrosion resistant. It is resistant to chemicals and easy to clean, making it ideal for garage or warehouses. The main difference between epoxy paint and normal paint is that when epoxy is present, the paint will adhere to the concrete surfaces much better, making it more durable and resistant. Without epoxy, a standard acrylic paint will eventually peel and flake, especially in high traffic areas. Also, epoxy paint has chemical and corrosion resistance properties. Concerning epoxy coatings, epoxy paint is not as durable as epoxy coating, but it still contains enough epoxy to provide decent protection for many applications. The main difference between epoxy paints and industrial epoxy flooring is that epoxy paint is only suitable for light-duty application and has never been intended to be used for industrial use. In contrast, Epoxy floor coatings are durable, industrial optimized resins that are designed to stand up to high traffic usages. Epoxy floor paint is more durable than traditional latex paint, but it is not as durable as epoxy coating. Another key difference between the two is the price. Epoxy paint is considerably cheaper. The application is also easier. With epoxy coating, there is a need for professional installation and a higher quality product. Regarding applying, it is almost applied like ordinary acrylic paints. 1 liter of floor paint will be almost sufficient to cover approximately 80 to 100 square meter feet per coat. It dries within 24 hours and reaches optimum scratch hardness after 3 to 4 days. Epoxy paints shield the substrate or floor from damage, especially from hidden chemicals. It is perfect for any household area where chemicals, heat, and other materials may be used. The acrylic formula can allow for customization in coloring, and this type of epoxy dries like regular paint. The epoxy component is attributed to the paint's resistance to the chemical stains on the floor like gasoline or oil, so it is often used on garage or workroom floors. Epoxy paint can cost almost $30 per gallon, which is enough to cover a few hundred square feet of space. Advantages of epoxy paint over acrylic paint. It shows comparably higher resistance to heavy shock, heat, chemicals, and water. Concerning its life cycle, it is cost effective. It is long lasting. Although it takes time to install, once the epoxy is in place, it lasts a long time. It is hard wearing, extremely durable, and will withstand a great deal of traffic. It provides good protection. Epoxy almost creates a shield for the flooring and will protect it from stains, cracking, and wear and tear. It is low maintenance. Epoxy is dust resistance. By creating a layer, epoxy helps prevent the dust from settling and circulating. It also creates a smooth and flat surface that is easy to clean. The other great benefit of epoxy paint is it is dust resistant because it is a topical sealer, meaning it sits on top of the material and doesn't penetrate the pores, creating a protective barrier which is important for cleaning. Ease of application and affordability are the biggest marketable factors of this product. In fact, the paint is ready to use and apply immediately. It is also naturally moisture resistant. Spill and stains won't be absorbed into the epoxy, and it can withstand high temperatures, making it a perfect choice for bathrooms, saunas, and swimming pools. Disadvantages of epoxy paints. Okay, it is slippery. In general, epoxy painted floors are skid resistant. However, oil-covered and wet epoxy surfaces can be very slippery. Epoxy paint isn't ideal for floor areas that are prone to slip or water on the floor. Second, by the way, it isn't temporary. Even though it is hard wearing and resistant, epoxy does need to replace eventually. Everyday wear and tear can initiate and develop cracks. If it is an area where heavy things, for example, are dropped onto the floor like a gym, this might be an issue. 3. There are concerns regarding its application as well. It takes a lot of preparation to ensure that the epoxy paint is applied effectively. There is a need to fill in all cracks and meticulously clean all grease, oil, or dirt from the surface. The application process itself is also time-consuming and tedious. It can take several days for the epoxy paint to dry properly, and there is a need to wait until the first coat is completely dry before applying the next layer. Its removal could also be an issue. It can be costly and labor-intensive to change the color, design, or to have epoxy removed. Compared to epoxy coatings, the low solid content within the paint results in a much thinner protective layer. It means that it won't last nearly as long as an epoxy coating. and it isn't as resistant to chemical as the other one. In other words, while it is more durable than traditional latex paint, it doesn't hold up to stains, chemicals, or abrasions very well. Epoxy flooring refers to a floor that has been coated with a protective layer of epoxy. The systems can comprise of several layers of thermosetting resins that are coated, troweled, or poured and generally applied on a concrete substrate. Once the resin layers completely cure, the floor system forms a strong and permanent bond, acting as an impervious and decorative barrier to protect the substrate. Epoxy is probably the most widely known resin floor technology as a result of its good mechanical and chemical resistant properties. Epoxy floors also can be customized into a wide range of colors, styles, effects, and decorative options. Epoxy flooring is mostly used for commercial settings such as office, clinics, and laboratories. This is in part due to the superior chemical resistance held by epoxy flooring. The specification selection process of epoxy flooring is influenced by the expected functionalities and protection requirements based on the frequent activities and operations of the facility. Types of epoxy floorings. In terms of aesthetics, epoxy floors are seamless, highly versatile, and available to be produced in wide range of colors, styles, effects, and decorative options. These properties makes them suitable for industrial and commercial facilities and locations. There are several general types of epoxy flooring, such as epoxy terrazzo flooring, epoxy flake coating, epoxy floor coating, self-leveling or SL epoxy flooring, anti-static epoxy flooring, epoxy screeds, etc. Epoxy floorings are tough, durable, and highly stain resistant. There are three different bases for epoxy flooring: water, solvent, and solid epoxy. Solvent-based epoxy paint is stronger and better at protecting the floor, but there is a risk of harmful fumes from the chemical used. Water-based epoxy flooring is less effective, but there is no toxin risk. And solid epoxy is expensive and harder to apply. Solid epoxy is the purest form of epoxy and contains no mixed solutions. Epoxy coating is most commonly used for flooring in situations with a high level of traffic. Due to its durability, epoxy coating is perfect for application in garages, basements, and warehouses. Epoxy flooring is extremely durable, making it a popular choice for workplaces and industrial settings. It is non-flammable and can withstand high traffic, chemical spills, and force damage. Epoxy flooring is also shock resistant and can last at least for 20 years when correctly installed. Bisphenol A is most widely used for flooring systems. The finished flooring should be cured according to the manufacturer's instructions. These generally require 1 to 3 days at 15 to 20 centigrade before allowing significant use by traffic, and 3 to 7 days at 15 to 20 centigrade before wet cleaning, allowing contact with chemicals or heavy trafficking. Adequate curing should always be allowed before wet testing the flooring for drainage or ponding. Epoxy floors are a good option for a variety of industrial and chemical environments, offering both aesthetic and performance. Epoxy flooring has several advantages and benefits compared to other floor coatings such as vinyl or polyurethanes. The benefits include aesthetic features and lower maintenance requirements, higher safety due to its non-slip profile, durability, abrasion and chemical resistance, and environmental stability. The main advantages of synthetic resins flooring can be summarized as a strong permanent bond to the concrete base, excellent resistance to a wide spectrum of aggressive chemicals, impermeable to liquids, increased toughness, durability, resilience, and resistance to impact or abrasion, hygienic and easily cleaned surfaces, greater resistance to cracking, low applied thicknesses, rapid installation and curing with minimum disruption to normal operations. There are some concerns with epoxy flooring. most prominently solvent-based epoxy floorings. However, modern epoxy flooring is very safe. The only danger that comes with epoxy is during installation or if it is incorrectly applied. During the installation of epoxy, the installer must wear a respirator to apply the finish. The area will need to be well ventilated. Second, when the epoxy coating is exposed to UV light, either directly or indirectly, it causes noticeable and permanent damage as a result of photodegradation, including loss of gloss, ambering, for example, turning to yellow, and for the colored one, chalking and breaking of the coating may also result. Resin floor systems that are applied improperly could result in delamination, chip and peel. This unwanted outcome is typically caused by poor surface preparation prior to the application of the final floor finish. Another type of floor failure is the occurrence of air bubbles or blisters in the resin flooring. This type of failure may be caused by too much moisture in the substrate. Using the wrong type of resinous floor systems for a mismatched environment can result in floor failure and ultimately substrate harm. Epoxy floors are hard and therefore there is a contact noise during walking. For this reason, flexible polyurethane floors are usually used in the office spaces and homes. Also, without underfloor heating, an epoxy floor feels somewhat cold, similar to tiled floors. Different resin types give different combinations of application characteristics and in-service performance. Factors influencing the selection of a flooring epoxy system include type and degree of traffic, temperature to which flooring will be exposed, nature and duration of any chemical contact with the floor, wet or dry service conditions, sleep resistance requirements, statics, ease of cleaning including hygiene requirement, moisture content of the substrate, time available for application and cure, prevailing site conditions at time of installation, and finally the cost. Therefore, it is not possible to provide a simple guide as to where to use different flooring types, since so many parameters can affect the decision for a particular situation. However, generally types 1 to 3 are suitable only for pedestrian or commercial use or the lighter industrial situation. Where there is a regular or heavy forklift truck traffic, the thicker flooring of type 4 and above will be the most suitable. For the heaviest usage, particularly where there is a possibility of significant impact damage, then flooring of type 7 and 8 will be appropriate. Okay, how much does epoxy flooring cost? Material supply and installation cost considerations will vary depending on the size, design, layout, and types of epoxy flooring. Total life cycle costs are usually advantageous for epoxy floors due to their low maintenance combined with longevity and durability, as project costs vary on a case-by-case basis. In very general terms, the service life will be proportional to the applied thickness of the synthetic resin flooring. However, many operational factors will directly affect the performance, including the severity of trafficking, wheel type and loading, the frequency and efficiency of cleaning, mechanical handling abuse, and other factors. In most industrial facilities, there will be a variety of situations for each of which a different type of synthetic resin flooring will be most appropriate. Conversely, there will be areas where some types are completely inappropriate. Self-leveling epoxy formulations are cure-fast systems and are designed to result in a dense, impervious, and seamless surface. These features result in an easy, clean, hygienic floor required in hospital, food processing plants, laboratories, pharmaceutical manufacturing areas, meat packing plants, etc. For self-leveling epoxy floors, often bisphenol A or bisphenol F resins are employed as the base resins. And in the formulation, curatives, diluents, a mixture of silica floor and silica sands, and a special additives such as anti-foaming agents are employed. For self-leveling formulations, cycloaliphatic amine curatives are commonly preferred as the systems based on these curing agents offer good chemical resistance, gloss, and color. If high chemical resistance is required, aromatic amines can be used for the curing process. However, because of their toxicity, these products are often substituted with cycloaliphatic amines. Thanks for your attention. I hope you found this video interesting. Please share your thoughts, comments, and questions, and I will come back to you soon.